Guys, this is Khan here. I live in Saudi Arabia studying 10th grade in Yamgo International School. Now what we'll talk about today is about graphing rational functions. Okay, after what we learned from rational functions, the idea, the concept of rational functions, let's go ahead and learn how to actually graph the rational functions. Now, we said from what we know is that the rational function basically has some identity that has a fraction here and polynomial at the top and polynomial at the bottom in the numerator and at the denominator. Now the whole graphing rational function involves fundamentally identifying the horizontal and vertical asymptotes, and then just plotting few points around them to discover the behavior of the graph. Now let's go to the whole process here. Now as you guys can see this function over here, we begin by identifying the asymptote, and we think to ourselves, identify the vertical asymptote of the denominator, which is -4. So this, the vertical asymptote that could never reach, is -4, because then it would just make the whole fraction to be equal to 0, which is undefined. Okay, so if x takes on value of -4, that would never happen. So it's a vertical asymptote. Okay, now so we have got the vertical asymptote to be -4. Now we need to figure out the horizontal asymptote, but we can do this by looking at the degree of the function. Okay, the degree of the function in the denominator, it is larger than into the numerator, so the horizontal asymptote is simply the x-axis. Now since there is no degree over here and the degree is larger, the first here is the constant, which is raised to the 0. Okay, so since the denominator degree is higher, the horizontal asymptote is simply the x-axis, or when x is equal to 0. Okay, so this is how we identify the vertical asymptote and horizontal asymptote, and then what we do is take x and y values and just graph few points around these corners to identify the behavior of this rational function over here. Okay, now we take the x and y values, we let x and y values take on these things, such as if you were to do this, you would basically have x and y values. Let x take on -5, which gives us -2. If let x takes on value -6, it would give out -1. If x takes on value -7, it would give out 2/3. If x takes on value -3, it would give out 2. If x takes on -2, it would give out 1. And if x takes on value of -1, it gives out 2/3. So you basically, what you need to do now is just plot few points around them. This is the horizontal asymptote, vertical asymptote, and few points just to identify the behavior of the rational graph. Okay, so it's easy as that. Okay, now even though the function may not be complicated, concept is basically the same. So basically what the thing is, even if the hard rational function is thrown at you, no matter what, this is basically the whole thing. Okay, you need to identify the vertical asymptote, you need to identify the horizontal asymptote, then you need to graph few points around those corners just to identify the behavior of the graph, the end behavior, or just any type of behavior that the graph basically makes. So before we actually move on to the last example of this section, let's go ahead and understand of the next concept is that even if if you have a polynomial over here and a polynomial here with large degrees, that won't make any difference. You go through the same process. So let's go and see how we actually accomplish this. So for example, if you have f of x is equal to 2x squared divided by x squared minus x minus 6. Say you have a function like this. Now what we learned in partial fraction is to decompose the fraction, which basically is named in algebra partial fraction decomposition. Okay, so here you decompose the denominator, which basically would be 2x squared over x minus 3 and x plus 2. Now what can x take on to make this give off its vertical asymptote? Well, basically you put it next to 0, so x minus 3, well, x would be given off as 3. So now you have x plus 2, which is 0, x can take on negative 2. So the vertical asymptote for this one is x equals 3 and x equals negative 2. So the vertical asymptote that we found is negative 2 and 3. Okay, now let's go ahead and identify the horizontal asymptote. Okay, now what can x take on to make this whole 0? Well, if 2 times something, let's say 0 squared is 0, so 0 squared is 0, 0 times 0, 2 is still 0, right? So x could be, for horizontal asymptote, x is equal to 0. Now how does it look like in the plane graph? Well, if we try to graph this, you have a vertical asymptote at negative 2. Right here is the vertical asymptote. The line will never touch this line, okay? Then you have it at 1, 2, 3. And again, this is rough diagram of the actual diagram of this graph. Okay, and the horizontal asymptote is this over here. X is equal to 0. Oops. Okay. Oops, I actually graphed it the wrong way, my bad. It's actually this way. X can take on the values negative 2. This one over here. 1, 2, 3. And it can take on the values 1 here, which is 2 over here. Okay, so the graph will never touch this line. They will just mark right here, then mark right here, mark like here, and mark right here. Something along those lines. Now this is just the actual visual graph of what we did in previous section of the graphs of sines and cosines. And we remember that the sine graph basically had a vertical asymptote and made a graph like this. And every time it touches, there's a horizontal vertical asymptote along with it, so it cannot touch that. Well, only the reason we have vertical asymptote is that to make this undefined. Okay? So I hope you guys enjoyed this video. Give it a like, comment, and subscribe. And there's a URL of Facebook page, of my page, and down below in the description area. Click on that page and give it a like, and whatever I post, give that a like as well. Come on guys, help me out here. And thank you for watching. Peace out guys.